Welcome, my name is Mike Bonifetti. It is my pleasure to introduce the Open System Interconnection Model, otherwise known as the OSI model. The OSI model was established in 1983 by the International Organization for Standardization. The OSI model is comprised of 7 functional layers. The layers provide communication to end users across different operating systems, as well as providing quick and correct communication across different networks. This image is a representation of the 7 layers of the OSI model, the layers being application, presentation, session, transport, network, data link, and physical. The application layer 7 supports applications and end user processes, communication partners and quality of services identified at this layer, as well as user authentication and privacy. Constraints on data syntax are also identified, and all activity is application specific. For example, file transfers, email, and other network software services. This is a representation of how the application layer works. Communication is done at the proxy layer with application servers and database servers. The presentation layer 6 provides independence from differences in data representation. It also formats and encrypts data to a network format and then translates the data back to an application format. It provides freedom from compatibility problems as well. The presentation layer is also referred to as the syntax layer. Here is an image of the presentation layer. Users make their requests and the data is changed to machine code and back when a reply is received. The session layer 5 establishes and manages connections between applications. It sets up, coordinates, and terminates conversations, exchanges, and dialogues. Here is a representation of the communication at the session layer. The transport layer 4 transfers data between end systems and hosts. It also handles end-to-end error recovery, flow control, and ensures complete data transfer. Here is a representation of the transport layer handling its assigned duties. The network layer 3 provides switching and routing technologies. It creates logical paths, otherwise known as virtual circuits. It transmits data from node to node, handles addressing, internet working, error handling, congestion control, and packet sequencing. Here is a visualization of how many different devices the network layer communicates with at any given time. The data link layer 2 encodes and decodes data packets into bits. It furnishes transmission protocols, handles errors in the physical layer, as well as flow control and frame synchronization. It contains 2 sublayers, the media access control and the logical link control. Here is a good representation of the data link layer performing its assigned tasks. Finally, the physical layer 1 conveys bit streams through the network at the electrical and mechanical level. For example, electrical impulse, light, or radio signal. It also provides hardware that means to send and receive data on a carrier and defines cables, cards, and physical aspects. Examples of protocols are Fast Ethernet, RS-232, and ATM. Here is a representation of the physical layer. Keep in mind this layer is the actual hardware tools that are used by users. This is a representation of how end users would communicate through the OSI model. A conversation of the OSI model would not be complete without discussing the real-world TCP/IP model. TCP stands for Transmission Control Protocol, and IP stands for Internet Protocol. The TCP/IP model was originally developed by the Department of Defense to be used under battlefield conditions. It was designed to be an automatic recovering phone line failure system. It is now used to connect various devices to a common network. Here is an image of the 4 layers of the TCP/IP model, the layers being application, transport, internet, and network access. The application layer 4 is the top layer above the transport layer. It defines application protocols and how host programs interface with the transport layer. This layer includes all high-level main protocols. For example, DNS, HTTP, Telnet, FTP, TFTP, SNMP, SMTP, DHCP, and quite frankly, the list goes on. The transport layer 3 is between the application and internet layer. It permits devices on the source and destination host to carry on a conversation. It defines level of service and status of connection used when transporting data. Its main protocols are TCP and UDP. The Internet Layer 2 is between the network access and transport layers. It is designed to pack data into data packets, which are called IP datagrams. The datagrams are encoded with the source and destination, and they are forwarded between hosts and networks. The Internet Layer routes all IP datagrams and rearranges them in proper order for delivery. Its main protocols are IP, ICMP, ARP, RARP, and IGMP. The Network Access Layer 1 is the bottom layer below the Internet Layer. It defines how data is physically sent and how bits are electrically or optically signaled by hardware devices that interface with the network. Examples are coaxial cable, optical fiber, and Category 5 twisted pair. Its main protocols are Ethernet, token ring, FDDI, frame relay, to name a few. By the way, the most popular LAN architecture used today is Ethernet. Here are several features that distinguish differences between the two models. It is noted the OSI model is a reference and theoretical model that is used as a reference tool. It is also noted that the OSI model was developed before protocols were, and that is based on a protocol-independent standard. Here is a good visualization of the OSI model compared to the real-world TCP/IP model. It is noted the OSI model's application, presentation, and session layers are all within the application layer in the TCP/IP model. Additionally, the OSI model's data link and physical layer are both within the TCP/IP model's network access layer. This concludes my presentation on the OSI model. I would like to thank everyone for taking the time to view my presentation. I hope you enjoyed it, and I wish everyone the best in their future endeavors.